So this is the condition on the right-hand sides. And what is that condition? This is solvability always of AX equal B. So AX equal B is solvable. Well, actually, we had an answer in the language of the column space. Can you remind me what that answer is? That was like our answer from earlier lecture. B had to be in the column space. Solvable if, when, exactly when, B is in the column space of A. Right? That just says that B has to be a combination of the columns, and of course, that's exactly what the equation is looking for. So that now I want to answer it the same answer, but in different language. Another way to answer this: if a combination of the rows of A gives the 0 row, if, and this was an example where it happened, some combination of the rows of A produced the 0 row, then what's the requirement on B? Since we're going to do the same thing to both sides of all equations, the same combination of the components of B has to give 0, right? So if there's a combination of the rows that gives the 0 row, then the same combination of the entries of B must give 0. And this isn't the 0 row, that's the 0 number. Okay. This is another way of saying, and it's not immediate, right? That these two statements are equivalent. But somehow they must be, because they're both equivalent to the solvability of the system. Okay, so we've got this sort of like question 0 is, does the system have a solution? Okay, I'll come back to discuss that further